Okay, so we are on page 81 in our workbooks. Okay, we have a given front view and a top view of a right regular triangular pyramid, cutting plane AA and starting point O. We have to draw the given front view, a sectional top view, sectional left view, and then the true shape. And then I want you to show all hidden detail, okay? So now, when we look at our top view, they already show us that these angles are on a 60 degrees, and we know that because when we take 360 divided by 3, it's going to give us a 60-degree angle. So from O, I'm just going to draw my 60 degrees, any given distance to both sides of my drawing. Okay, and then I'm going to measure my 52. And from O, scribe 52. And 52. Line across, and then I need to get my center here. Now I'm not drawing anything in solid yet because it's going to be cut, okay? Even though it's a top view, it won't be in solid yet because I'm doing the section on that. So now to get the center of my triangular pyramid, I have one line, and it will always be like this. One line will either be on an angle that you have a set square of, or it will be on a 90-degree or 0-degree angle, okay? So then the other one, to find that, we need to do the bisection, which I've taught you guys. Bisect any of the given corners. It's the same as bisecting a line, okay? So it's just a corner, and we work only from the corner and not from the edges of the line. And then this is now my center. So there's my center, and now I can go and I can do my projection to my front view. And I will get an auxiliary, not an auxiliary, just an XY axis. Okay, so we have our XY, and then I'm going to draw the base of my triangular pyramid, and then I need to get my height, which is 73. So that will be the top of my pyramid, and I can take all my lines to the top there. And this I will draw in A lines because it is not a cut view, it is the full front view. Okay, so a full front view. And then I want to do my cutting plane, and remember a cutting plane is in B lines, and it is a center line. So I'll measure my 2 dimensions. The first one from the bottom is 21. So on my straight line, I'm going to scribe my 21, not on the angle, remember that. So on the straight line, and then the next one, 54. Sorry, I think it moved. Not. 54. And project them in construction to where they are supposed to be. And then I can go and draw my cutting plane through those points. And we label it cutting plane A. And then that is now the given views done. Okay, so we've done the first number 1, which is to draw the given front view. Okay, so you see you always have to first draw the top view or the view that gives us the true shape of the drawing, which will then sometimes be the auxiliary view. Now I need to find my section. So what I just want to do is, before we start with that, I'm just going to do numbering or naming. It doesn't have to actually be numbers. So I just like to do numbering because when I go to a different point, I can actually use alphabets. Okay, so I have corners 1, 2, and 3. And then the top here, I will make either T or P. Okay, I like to use P because it's the peak of a mountain. Okay, so now, where my section now cuts, sorry, I haven't transferred the bottom. This is 2, this is 1, and this is 3. When I transfer my section, so where it touches one of the lines, I'm going to project it down. Okay, this one is parallel to that line, so I don't know where it is, so that is the tricky little bit. So there, this one I can project down. Okay, so I can find 2 points thus far. This line goes, the cut goes on line 2 to P. So on line 2, so there's 2 to P. So on this line. This one goes on 3 to P. So there's 3, there's P on the line that goes from 3 to P. So I have 2 points of my cut now already there. So we found these 2 points of our cutting plane. Now we cannot find this one because it is parallel to an axis, okay, which is now basically these 2 axes, né? Okay, so it's parallel to that. So now how do I find that? This is an equilateral triangle. So that means that all these sides are exactly the same thing. So what I can do now is I can go and project this point to any of my other 2 sides. So I'm going to project it to my right hand side, so which is line 3 to P. I'm going to project that point down to line 3 to P, but that's not the place where my cut is. So now what I'm going to do is I'm going to set my compass on P to that point. And you will do an arc, and that gives me that cut there. Okay, so you see what I did. I projected that line across, straight down to there, set my compass on P to that point that I got, and then I transferred it to the line where I want it on. Because it's an equilateral triangle, I can do that. Okay, so then I'm going to connect these points, and they will be A lines, because it is my cut. And now here you must make sure that you don't connect it to the wrong one, hey? So please be attentive on that. There, and then I'm going to do my hatching on my 45-degree angle. And these are B lines. And this is a very small space, so we'll use the 2 millimeter hatching. Okay, so there's my hatching. Now, what stays and what goes? We are looking at it from the top. So what is the closest part to me on the cutting plane gets taken away. So I'm standing here where my pencil is, and then I'm taking away this part which my hand is covering. So I can see from the cut to 3, firstly. So from the cut to 3, I can see from the cut to 1, from the cut to 1, and I can see here from the cut to 2, which is just this little small part. So now that means that the base does not get sectioned away. It's only the peak that is sectioned away. So now obviously I need to connect lines 1, 2, and 3, and then 3 back at 1. So as A lines. Okay, that was an A line. And that is now my top view. So this was the difficult part on this drawing here. Ne? Now when I'm going to go and I'm going to do my left view, which will now be on my right hand side, and please pay attention on which views goes where, because it's first angle. So XY axis. And now I'm not using my 45-degree method. I'm going to use my rule of similarity from my top view. So 2 and 3 are lines. Here they are aligned. So when I scribe here, this will be point numbers 2 and 3. Okay? And then from my XY to the peak, follow the peak. There's the peak. And then from the XY to 1, follow, there's 1. Okay? So remember now, 3 and 2 is a line, but on this view that we are looking at it, it looks like a point view. Okay? It's a point. So I'm going to explain that to you now. It is, for example, when you see my pencil now here, it's a point. It's just one little dot. So it's the same as this point here for 2 and 3. It's a little dot. But as soon as I change my view here, it actually has numbers 2 and number 3. So that is why it's called a point view. Okay, so now I have that. I'm going to project my cut across. And now I need to go and see where it touches. So this one touches on line 2 to P. This one touches on 1 to P. And then that one touches on 3 to P. So, wait, this one I made on the wrong place. There's 1 to P. Sorry. Okay, so now, solid lines for my cut. Do my 45-degree hatching. Okay, and this one's a little bit bigger, so you can use around about 3 mils of hatching. You don't have to use 2 mils. 3 or 4 mils is also fine. And remember, I said you don't actually even have to go and measure the hatching. You see, I'm just using my millimeter lines to actually get my hatching distance. So I'm setting it on that point there. You do actually, with these set squares, here's hatching guides here on the side. Okay, so that's hatching guides. You can go and use them. It's not necessary to use them. As you see, I never use them. Okay, so there we go. That is what we have there. And then now, I need to look at my view. I'm looking at it from the left-hand side. So this is still closest to me. So again, the same lines are going to be solid. So cut to 2, cut to 1, cut to 3. They are still going to be the same. So I can see now here the cut to 1. And then this line we've already drawn solid up to there, because that was on the cut, because it's a point view. They fall on the same axis. And then obviously the base isn't cut off, so I will be able to see my base there. Okay, so this is now then the views completed. Now they're asking for a very funny thing called the true shape of the cut surface. They do not indicate in which direction, but I've already drawn on my right-hand side, so I need to show the cut on my left-hand side. Okay, so this is my cut. They want to see the true distance of from this point to that point to that point, as well as then the actual true lengths, which we can see, or actually the true widths, if I'm looking at it like that, the true width here. But here I need the true length. So what I do with this view now, the true shape, is on a pyramid, we work as follow. I will do a prism with you guys as well. So pyramid from the lowest part of my cutting plane. Okay, if this is faced the opposite direction, treat it the same way, the closest to the base basically, if I can say that, or to the flat surface. So if this was turned around, you would have worked from the top of the cut, okay? So there, get an XY axis, and you don't have to label it. It's just there for your purpose of what we're going to do now. Then, where that line touches, you set your compass. Then to wherever your cutting plane touches a line, we're going to project that across to that cut that to that axis that I just got. There. This means that the distance here and here is exactly the same as the distance there and there, because I'm using a curve and not a straight line to project it. So it gives me a true length, okay? So we will still do true lengths and so forth, but you guys are now already getting introduced to true lengths. And then I project these lines across, okay? Now, when I do my true shape, I always work on a view that has the cut. So you can work from your top view or this view, which is now your left view. Okay? So never ever work from the auxiliary view when the view is on an angle to find your true shape. Okay? The auxiliary view is only to find these views basically if we're looking at it like that. Okay, so I'm going to take, you'll see that basically this distance and that distance will be the same now. So I can use any of them. You take the distance from where this point is now, on your XY, to where the cut is on your top view. And then, on that point, I'm going to scribe it. So you see I scribed it on that point, okay? Then, next, here, there, you see to the next one, which is number 1. Follow the line, follow the scribe, there. And then here, on the XY, to number 3, follow the line, to the XY, there. And that is now my true shape of my cut surface. There, there, and there. That's my true shape, and then I'm just going to do my hatching again on a 45-degree angle. That does not change. And then important on this, you have to label it. At the bottom always, between round about 3 millimeters, you see I don't even draw a line. You can draw just a reference line at the bottom and then write in capital letters, okay? And then that is my view done. I don't see any hidden detail, because all lines falls together with one another, and I'm looking at it from here so I can see one. Okay, so one is closest to me and these lines are further, so I will see all my lines and no hidden detail is required.